This video is the second video for the hints of our homework assignment number 2, part B. Yeah. All right. Last 5 questions in this video. Yeah. All right, so let's start the first question. I mentioned last time number 11. It's a very easy question. I do not need to say much about this one. Here I just say after our Thursday's class, yeah, that is December 4th. Okay, all right. After Thursday's class, you can do it easily. All right, yeah, easily. Okay, yeah. All right, so now let's do the last 4 questions. Number 12, binary search, 28-element ordered array. Yeah. But there is one condition. You need to use it when you handle your data. That is, the given key appears between 6th element and the 24th element. Yeah, but here this information is hidden. Although this is a fact, it is a hidden fact. Yeah, at the runtime. Yeah, so that means you need to use the original binary search. You cannot make any adjustment. Yeah, no adjustment. On the binary search. Is allowed. Okay? Yeah. So, all right. So that means when you build the binary tree, remember? Yeah. So when we calculate the average case efficiency, we need to draw a binary tree. Yeah. So you need to use all the elements in this array. Okay? Yeah. All right? Yeah. Then many in the middle, the last few. Yeah. All right, 23 here. All right. All right, yeah. So your binary tree is built on all the elements. All. Yeah. Then you draw the binary tree. Okay? All right. Yeah. When we do the binary search, yeah, the first comparison, yeah, then the second comparison, and the third level, and so on. Okay? Yeah. All the way down. Yeah. As we did in our module 4. So you need to look at module 4. Part B.3. Yeah. No? B.2, B.3, yeah, average case efficiency. Yeah, all right, yeah, all right. So then, But that one is for the whole tree. Okay, all right. Then, but after that, then we need to do something different. When we calculate the average case efficiency, yeah, we need to do something different. Calculate the average case efficiency then we need to apply this hidden fact. Yeah. So this given condition is useful here. Okay, all right. So inclusive, the given key between in this range. Okay, key, this range. Range for the key. Because when we do the statistics on the average case efficiency, think about, suppose we do experiments many times, okay? Yeah. If the data follows this hidden property, then all the experiments, for all those experiments, the key falls in this range. Okay? Yeah. Yeah. And these two parts, yeah, never occur. Okay? Never occur. Yeah. Then the real, the best formula when we, because we want to describe our average case efficiency in the best way. Okay? For the best way, these nodes should be removed. Okay? Yeah. These nodes. So remove. So on your binary tree, remove all those nodes that do not participate in the calculation. Yeah. Then, in the remaining part, then you count number of nodes in each level. Okay? Each level. All right? Yeah. So then, level 1 times the number of nodes in level 1, all right? Plus 2 comparisons, level 2 times number of comparisons in number of nodes in level 2. 3 times 3, and so on, okay? Yeah. All right. Then, total number of nodes. Total number of nodes in the range. In the range. Okay? Yeah? So that's the right way to calculate question number 12. Okay? Yeah. Yeah. If you do your calculation carefully, then you won't miss it. Yeah. All right? Yeah. Follow, this guideline closely. Yeah. Do your calculation carefully, then you won't miss it. Yeah. All right. Now let's move to the last 3 questions. That's the challenging question, challenging computation question. Last 3. So this time I do not give you 5. I only give you 3 challenging questions. Yeah. All right. So in our final, I will also give you 3. Yeah. Yeah. final, yeah, you will have 3. I don't need to write it. So in the final exam, okay, not 5. Yeah, 5 because you need more time, right? Yeah, so 3 already good enough. Yeah. All right. Yeah. Number 13, 7-element array, distinct elements. Yeah. How many comparisons? Find the median of this array for the worst case. Yeah. All right. So here, I want to give you the hints for, two different ways you can choose. So which one you can get? Yeah. Yeah. So the first way, weak solution. Yeah. The second way, strong solution. Okay? Yeah. Yeah. These 2 different ways. Yeah. All right. So for weak solutions, yeah, there is a relatively easy way you can solve. So here I give you some important information. Yeah. All right. For the weak solution, here I like to give you some so let me use the space here. Because this second half we have relatively more space. Let me use the space, second half page to explain. Here, I want to introduce an important and a very useful operation related to our merge operation. You're familiar with the merge operation, right? In our merge sort, we spent a lot of time study the merge operation. Yeah. The best case formula, the worst case formula, the standard merge operation. Here, I want to introduce a slightly different merge operation. So I call it partial merge operation. Okay? Yeah. Yeah, so from this name you can see we do not run the full merge operation. Yeah. We run the merge operation partially. Yeah. Yeah. So we own because somewhere in the middle. Yeah. As soon as we get our solution, we stop immediately. Okay? All right. That's the partial merge operation. Yeah. Here, because this is a general way to find a solution. So I describe it here. Yeah. So later when we need to use it, so then we can use it. Okay? All right. Yeah. So partial merge operation. Yeah. That's very easy. Yeah. Yeah. So how to do it? The details. Yeah. We assume we have 2 ordered arrays, right? Yeah. So the first one with size A, the second one with the size B ordered array. All right? Yeah. Yeah. Here I assume you are familiar with the standard merge operation. Okay? All right. All right. So this partial merge operation, we just apply the standard merge operation a few steps. Okay? Yeah. So here I assume this one is unordered. This one is ordered. Okay, all right. Yeah. Then, two ways to apply. Yeah. The first way, yeah, from the low end. Yeah. Low end, that way, that's our, same as our standard merge operation. Yeah. Low end. Yeah. Because our second way from the high end. Yeah. Low end, yeah. Remember our first comparison, the smallest first comparison, yeah. We will get first smallest. All right? Then the second comparison, yeah, second comparison, yeah. We will get second smallest, right? Smallest. And so on, right? And so on. Yeah. So here, think about if we need to find the kth smallest, element. Yeah. We just need k comparisons, right? Okay? Yeah. After k comparisons, we get the kth smallest. Okay? Yeah. Then we stop immediately. Okay? Yeah. Stop immediately. Because we already have the solution. You do not need to complete your whole standard merge operation. Okay? Unnecessary. Yeah. So that's what I mean, partial merge operation. Okay? All right? Similarly, from the high end, yeah, because sometimes we need to find the largest, right? Yeah. Then we need to, use the same approach, but just from a different end. Okay? Yeah. So this time, let's say we need to find the kth largest element, right? Yeah, sometimes because it is more convenient to find the kth largest element. Yeah. Then the first come from the high end, yeah, upper and higher, whatever you call it. Yeah, you can find a, good way to call it. So first largest, one comparison. You get the first largest. Okay? Then the second comparison, some way, yeah, the similar to the standard, yeah, because the standard merge, we always run it from the low end, right? But here we modify it, yeah, just the opposite way against our standard merge operation. We run it from the high end, right? Yeah. So the second largest. Okay. Yeah. So then we keep going, and still, our goal, we want to get the kth largest. How about that? Kth largest, then you need, or we need, k comparisons for the kth largest. Okay? Then you're done. We stop immediately. So that's the, modified merge operation, the partial merge operation. Okay? All right? Then, now, yeah, because this way is very useful. In many of our questions, this way is very useful. Then we can go back to look at our last three questions. All right. Number 13, 7-element array. Go find a median. Okay? Median. So what is the median? Fourth smallest, right? Yeah. In 7-element array, the median is the fourth smallest or fourth largest. Sorry. Yeah. Fourth largest. Okay, all right. Now, let's look at the weak solution. First, let's consider the weak solution. All right. Weak solution. First, given the array, you need to split the given array into two subarray. First, split. Into two subarrays. Yeah, yeah. How to split? You have different ways, right? Yeah. All right. So here you have 7 elements here. Yeah. 7. So you have freedom to do the split. Okay. For example, you can split here the first subarray, the second subarray. Okay. First sub, second sub. Okay. All right. Or, if you want to split in another way, it's also okay. Yeah. First subarray, second subarray. Yeah. Also okay, right? Yeah. All right. Yeah. Then, the first step. Next step, can you sort the first subarray with certain number combinations? Can you sort with second? Yeah. Because when the sizes of your two subarrays become relatively small, then you can use fewer comparisons to sort these two subarrays, right? Yeah. Here you can also sort. Okay, you can also sort. Yeah. And you know the best way to sort these two relatively small subarrays, right? Yeah. Yeah. We did in class. Yeah. Yeah. So we did in class. Yeah. You can find the solutions sorting these two subarrays in our notes easily. Yeah. All right. After that, you have two ordered arrays, right? Then find the fourth smallest or fourth largest. Can you apply the partial merge operation? Right? Yeah. Then you can apply the partial merge up. Okay? Yeah. Right? Yeah. Yeah, but this is the way to get a weak solution, right? Yeah. Yeah. Just one more comparison than the strong solution. Yeah, strong solution. You can do one comparison better than this weak. Yeah. Here I can also give you the hint for the strong. For the strong solution. I need some space. Let me use some space here. Okay? Yeah. Yeah. For the strong solution, yeah, then you need to use a completely different idea. Yeah. Yeah. this partial merge way, simple, simple, relatively simple, but you cannot get the best solution. Sometimes, sometimes you cannot get the best solution. All right, for the strong solution, because you have 7 elements, right? 7 elements. Let's take 5 of the 7 elements. 7 elements first. Okay, any 5, it's not important. Or for simplicity, you just take first 5. Okay, all right. Then, when you have 5, you find the median first. Find its median. We did it in class, right? We did it in our FBR number 6. You can find it in our notes, the solution. Okay, all right. So after you find a median, you know how many comparisons you need to find the median of this 5 subarray. Then look at this median. Okay, suppose this is that median. But this is not the final median. Okay, the median of 5. Oh, touch it. This median. Anyway, median of 5. Okay, all right. So let me write the space. Oh, what's wrong? Oh, I want to erase it. Oh, I cannot erase. Oh, anyway, if I cannot erase, let me, use this place. Okay, all right. This place. All right. Median, but this is median. I'll put a subscript 5 here. Okay, all right. The solution. So you need how many comparisons you need based on the solution. All right. Then other than this local median, we can call it a local median, not a global median. Okay. All right. So there are 4 elements, but there are 2 elements above this median, greater than this median. Okay. You also know there are 2 elements below this median. Okay. Less than this median. All right. But the order of these you may not know. Okay. You may not know the order based on our algorithm, but you know which 2 elements are greater than the median, which 2 elements are smaller than the median, but you don't know the order between those 2 greater than 2 elements higher than the median and the 2 elements lower than. You don't know the order between those 2 elements. So that's what we get then the next step, the element number 6, element number 7 remaining, can you compare it to the median and do some analysis? To get a strong solution. This way. Okay? In this way, but you need to consider the worst case. when you do comparison here, yeah, you need to target the worst case. Not the best case, okay? Not the best case, worst case. To get the strong solution, okay? Yeah, all right. Yeah, so that's the number 13. Number 14, yes. Number 14, see? Partially ordered array, another subarray ordered, and the remaining, you have element 7, yeah. So the main idea here, yeah. So there is a simple way to solve it, yeah. Because your goal, you need to sort the whole array, right? Sort the whole array. Yeah. All right. Then use the merge operation. Yeah. Use the merge operation. You can sort, right? Yeah. Yeah. So here it's not a partial merge, because when you do sort, so you use the full merge operation, not partial. Yeah. Yeah. When you do a selection problem, find the kth, largest or smallest, then you can consider using partial merge. Yeah, but here it's a sorting problem. So you need to apply the standard merge operation. All right, so that's number 14. Yeah, so idea is very simple. Yeah. You just, try to connect to the merge operation. Then you're halfway there. Okay, if we can connect it to the merge operation, then you're halfway there. Okay. All right, yeah. But when you apply the formula, use the worst case formula. Okay, yeah. Merge, we have best case formula, worst case formula, but you need to apply the worst case formula. All right. Then the last one, yeah. Last one, the hardest, yeah. The hardest, yeah. Find the median, yeah. So you have two ways. The first way is the weak solution. Okay, weak solution, similar to the idea. Similar to the idea in number 13 question. Okay, yeah. Yeah. Split this 9-element array into 2 subarrays. Then find the median. Okay? Sort. Yeah. Split. So you sort first subarray, second subarray, then apply partial merge. Okay? Yeah. So that's the, for weak solution. Okay? One more comparison than the best strong solution. Okay, just one more comparison than the strong. All right. Then the strong solution, I also give you the hint. If you want to try, you can do one comparison better than the weak solution. Yeah. Okay. So strong solution. All right. So this time, your arrangement should be completely different. Yeah. So this time, your arrangement. All right. All right. Group these 9-element array into 3-element subgroups. Okay. All right. So let's say x1, x2. X3, the first group, second group, x6, x5, x4. Remember, I give you the description of the general selection problem. Okay? So here we use some of the idea in that the general selection problem. Okay? 7. All right. First, you sort. Yeah. Sort each 3-element subarray. With 3 comparisons, right? For the worst case. 3 comparisons each, okay? Yeah. But we have 3 subarrays, okay? Yeah, so you know, yeah. So 3 here, 3 here, 3 here, right? Yeah. So you get a sorted. Yeah. All right. Sorted, yeah, we assume, you know, so this is the, you know, sorting order, okay? All right. Like that, yeah. So let me just, you know, erase. Yeah. Okay. I need to, sorry, oh, maybe it's too much. All right, yeah. In this time, let me just. Oh. Yeah, the software not very friendly. Yeah. Yeah. All right. Okay. Yeah. Then we assume median of the first ordered subarray, median of the second subarray, third. Next round, can we sort these 3 median? Okay, sort these 3 medians. Okay, yeah. And when you sort, you can assume this is the order. Okay, yeah, because you take, you know, without loss of generality, you can assume this order, right? Yeah? All right. And this is the median of these 3 medians, x5. Okay? All right. After that, then you need to do your analysis work. Okay? Yeah. In your analysis work, yeah, try to eliminate as many elements as possible. Okay? Try to eliminate as many elements as possible. Okay? All right. So then, after the elimination, you reduce the problem size. Then, you complete the remaining part. Okay? Yeah. Complete the remaining part. Yeah. Yeah. You need to do some more analysis work. Yeah. So it is challenging. It is the hardest question of this assignment. Yeah. So that's in order to get a strong solution, yeah, you need to really do some tough work. Okay? Yeah. Tough work. So this part is the, tough work. After your elimination, you need to do some tough work. Yeah. But I think it is doable. Yeah. So if you if you have time, yeah, so you can try a little bit, yeah, yeah. But if you feel too hard, so then you just take the weak solution. Weak solution is not that hard. Okay? Yeah. Strong solution is hard. Yeah. All right, so let me stop right here. Yeah. So try your best to, solve these. Oh, sorry. Oh, yeah. I complete all of them, right? Yeah. Because here I see a lot of space here. So, yeah, I feel I may not complete all the questions. Yeah, it looks like I covered all the questions. All right. Yeah. Okay. Yeah. All right. In order to let you do the best you can, yeah, I'm thinking about I may extend your deadline, 1 or 2 days. Yeah. So now I'm thinking about 1 day or 2 days. Yeah. Yeah. Minimum 1 day, maximum 2 days. Yeah. In order to give you a chance to do the best you can. Yeah. So that's the possibility. Yeah. All right. Yeah. That's all we have. Yeah. All right. Yeah. Let me stop right here.